Hey Year 12, welcome to our latest integration video. What we want to look at today, right, it's going to be another two-parter. In the first video today, we're going to look at what happens when I'm considering or I'm determining the area not between a curve and the x-axis or a y-axis, because we did that earlier on today, but what happens when it's between two different curves and the x-axis. Between two different curves and the x-axis. What are we going to do? We're going to dissect it into two areas, right, or more perhaps, but we're going to dissect it. In the other video, just a heads up, we're going to look at what happens when it is the area between two curves, right? But in this first one, under a combination of curves, more than one. So here we go, we've got two curves, y equals x squared, y equals x minus 2 all squared. These are both parabolas. They, let me have a look, they both have a minimum on the x-axis. This passes through the origin. What's going to make this 0? It's going to be, it's perfect square, it's going to be where x equals 2, 2 minus 2 all squared equals 0, okay? Let's sketch these. Zero axis, x squared, something like that. Now that's going to be 2 there. So this is going to be y equals x squared. This is going to be y equals x minus 2 all squared. That's part A done. Part B, shade the region bound by this curve and the x-axis. That, of course, is this smashing little area here. Okay, that's what we're going to be interested in. And finally, find the area of that region. What I need to do, I need to dissect this into the area between the x-axis and this curve, right, y equals x squared, between here and, what's that point there? Well, it looks symmetrical. We're pretty sure it's 1. I'll show you in a moment, just to remind you how we're going to calculate that. So between y equals x squared and the x-axis, between y equals x minus 2 all squared and the x-axis. Right? Let's just be thorough about this and show that that point there is 1. Right? These two lines will intersect when they are equal when the y values are equal. No? When those y values are equal. So let's make those equivalent, and that means that x squared equals x minus 2 all squared, which means that x squared equals x squared minus 4x plus 4. Right, cancel out this x squared. We get 4x equals 4 and x equals 1. I don't particularly care what y is, because we just want that little limit there. Okay, so to find the area is going to be equal to the integral from 0 to 1 of the first curve, which is x squared dx, plus my second area, which is the integral this time from 1 to 2 of x minus 2 all squared dx. Right, so those two areas added together, which is equal to a third x cubed between 0 and 1 plus, now we expand that out and we get x squared minus 4x plus 4, right, this expansion here, because that's how we need to do it, and I get 1/3 x cubed minus 2x squared plus 4x between 1 and 2, and then I substitute in there. I get 1/3 there plus, I'm pretty sure I get 8/3 minus 7/3. Okay, substitute in that. If you're not convinced, sort of work through those things, but just make things fast. We get this, and look, unsurprisingly, this little part here, 1/3, that's my first part of the area. Unsurprisingly, those two regions, when I dissect them, they're both going to be equal. Right? They're both equal to 1/3. My total area equals 2/3 of square unit. Okay, 2/3 of square unit. That's our first video. Pause, rewind, check it out. But it's the first one. Check out the second one. It's going to be the area between two curves. It'll be great.